Good afternoon, everybody, and welcome to the talk, Empowering People to Experience the World with Spatial Data Science, of course. So my name is Michele, and I'm a data scientist at Booking.com and a PhD candidate at King's College London. At Booking, I work on representation learning for location data, driving geospatial initiatives to enrich our machine learning models with location intelligence. Today, I'm happy to present an overview of what we do at Booking in terms of spatial data science. So I'm going to give you first a bit of context, talking about what kind of data we have at our disposal and how we leverage that, in particular, to tackle two main challenges. First of all, finding the best destination for our users, so modeling really where people go, and then finding the best experience once they are at their arrival destination. So what can we provide in terms of unique experiences? So let me dive straight into it by actually asking you a first question, a first quiz. Can you guess, given this screenshot of our website, where we deploy spatial data? I'm going to give you a couple of seconds to think about it. There are some obvious places that I'm kind of hinting at with my mouse here, and some not so obvious places. So I hope you had enough time. So the answer to where we use spatial data at Booking is, well, actually, pretty much everywhere. Matter of fact, leveraging spatial data and spatial data science is at the core of what we do. And this can be seen across a vast range of products. Of course, as I was hinting, in usual components such as the map view in the map widget, or in the name of the destination, in the name of the countries and regions and so on, but also really across a vast range of products such as flights, car rentals, and attractions, and to enrich the content that we offer with ancillary information such as distance from city center, calculated with our with our routing engine, with amenities that are nearby, and so on and so forth. So in a sense, Booking can be seen as a massive geolocation search engine, and which is built on top of a vast volume of geo-content. And I mean, why? Well, because of course, travel is geo-contextual. Traveling is all about the experiences that you have in the place, the food you eat, the attractions that you see. So how do we best leverage this data to provide fantastic experience to our customers? Let me present you exactly first the data that we use. So the first data set is what I would consider the most traditional. Somebody mentioned before the GIS industry. This is what most professionals in that industry will recognize. As traditional GIS primitives, lat-long pairings and polygons. In a sense, geographic entities such as regions, cities, airports, and hotels. But these already are quite interesting, not only for the granularity at our disposal, but also in terms of the ancillary information that we collect for every of those items. So, for instance, we have data points and reviews attached, images and reviews attached to these data points. We have location scores. We have, of course, the address and nearby attraction that can really help us to give a better sense of what is around a certain destination. A superset, in a sense of this, is our points of interest data set. So you can see here, points of interest are really like landmarks at the end of the day, sightseeing, interesting things to see in a destination. And this is organized in a 4-level taxonomy, which is fairly standard practice in the industry. But this allows us to model semantic relationships between these amenities, to describe them also with a varying degree of detail. So, for instance, we know that a certain place can be classified as social or food dining or restaurant, up to the level of detail of the kind of cuisine that is there. And this data set was mostly manually curated, but until recently, right? But I'm actually pretty proud to say that we started actually consuming OSM data as well. I'm sure I don't have to introduce OSM, the Wikipedia of maps, to the audience here. And how do we consume it? Well, first of all, to build features for machine learning models. And secondly, we are exactly exploring how to scale our inventory with it. OSM contains a plethora of geolocated information. I think there are around 6 billion items and growing on OSM. And quite a few of them are actually relevant for the travel industry. You can see here the example of mountain peaks in Switzerland. And so these two are like traditional GIS sources, let's say. With the third data source, text, we enter a more unknown, unexplored realm. So text for us, it's actually a massive source of data, and a massive source that, if mined correctly, can provide very accurate location information. So in the example here, you can see some reviews from our users where they explicitly mention items such amenities, like this customer is mentioning train station nearby a certain hotel. This customer is saying that the hotel is in the city center, in a great location. So really, we know that that by mining location data, we can enrich and gain much more information about our points of interest and our properties. Similarly, images can play a similar role. Images are also usually manually created in the case of emotional products where we need a particular evocative image. But also, and this is one of our advantages, that we have images provided by our partners, so the hoteliers, and also by our guests. So once again, partner-generated and user-generated content. And this is very interesting because not only these images are geolocated, but they tell us different point of views, different stories about a certain place that, again, we can anchor to space to really model our properties and perform analytical tasks. So actually, talking about analytical tasks, after this overview of the data that we have, let me now introduce the first challenge, which is really finding the best destination for our users. So where to start? Actually, the challenge is precisely this: where do we start? In a sense, it's destination selection, how to identify suitable destination given an input search string. So in the example here of Rome, you can see in the plot that all these red dots are really our properties in and nearby Rome. And the map inlet shows the Città Metropolitana, the metropolitan area of Rome. Now, the challenge here is that, as you can see, the actual Rome, so the city itself, it's much smaller than the scattered dispersion of these properties. So for us, it's quite interesting and quite challenging to model where do the boundary of a city end, which is what really is a destination. And the limitation of this challenge is that there really is no ground truth. So to make it even more clear, when somebody looks for Rome, is she looking for Fiumicino Airport, which is technically part of Rome but very far distant from the city center, or should we recommend a hotel in the city center? This is a fairly open question, really. And of course, there are some naive solutions that can be adopted, such as deploying administrative boundaries, but of course, with this we impose constraints on space. These are fixed entities. We can sort of roll our own boundaries using computational geometry techniques like envelopes and so on, or perform or roll our own boundaries with spatial tessellations. You see here an example of an aggregation based using H3 hexagons. And okay, these are fairly naive, but they produce a boundary of a destination which is somewhat similar to what we see in the map inlet. The problem of this approach is that this is static. So can we do better? Of course. This is a nice example by a colleague of mine, Elias, who modeled, again, destination via click-through rate. So what we see here is a map, is a graph of a substitute location. What do I mean by this? So here is actually a destination, which is London. So actually somebody searched for the term London, but actually ended up booking hotel somewhere else, such as in Milton Keynes, in Oxford, in Reading, even in Brighton. And this is a much more nuanced way than what we were seeing before. The first actually result of this is that this allow us to capture spillovers, like from a main touristic regional destination to nearby areas, which is of course interesting because of the hierarchy implications that this has. Secondly, and this came out of course in the intro to this talk, these allow us to really account for the fact that destinations are not fixed in time nor in space. So this is the same picture from last year to this year, and of course, as we might expect, we see major shift in what people, in the way that people travel. And this is an example for London where we see a sort of contraction, but we also have example of an increasing demand for domestic travel and nature-related activities. But the key point is really that boundaries of destinations are not fixed. Now, an extension of the previous example is the case of the flights product. So before we saw a customer looking to travel towards Brighton and Oxford, looking at London as an intermediate destination, as a sort of landing place. Now the challenge becomes, given a set of possible destination candidates, can we identify the most convenient airport for our customer? And to solve this spatial data challenge, we use an established technique, really, which is that we model the propensity of customers to depart from a given airport by a gravity model. A gravity model is, as I said, it's fairly established. I think they are probably more than 70-year-old. They were first proposed by George Zipt, inspired by, of course, Newton's law of gravitation. And they used to model human migration patterns. So to model this term TIJ of migratory flow between two communities, I and J, approximated by the proportion of the size of these two communities over the inverse of their distance between them. And this is to account for the friction of space, in a sense, for the cost effect in terms of distance traveled. So by deploying this model, we managed to capture in a quantifiable way the boundaries of a destination, given an exit point, so a departure point from a region, which is the airport, of course. Right, so once we kind of get a sense of where our users want to go and how we can best provide actually the properties in the area that are most suitable for them, well, what can we surface as content for them to experience as they are there? So, in a sense, what the experiences are there to see? And this is really where we understand the potential of the heterogeneous spatial data sources that I mentioned at the beginning of the talk. So the spatial data challenge here is, for instance, it's well known that Italy or France produces some of the best wines in the world. But how do we quantify that in a way that is relevant for our users? Well, social proof, using, again, data generated by our users, can be a compelling storytelling and recommendation tool because of the trust that our users put in people with similar interests. So how do we model that? Well, borrowing from NLP, from natural language processing, we can use topic modeling to uncover dominant travel themes in a user's endorsements. I mentioned before, reviews. Endorsements are a set of labels that our customer attach to a city after they are reviewing, they're writing the review. So this is precisely what my colleague Mike has done in this interesting analysis. He created a simple bag of words model where endorsements were clustered based on the type and frequency, resulting effectively in this destination topic explorer sort of tool. You can see here, for instance, that when we compare our endorsement model for wine against ground truth, against known wine regions in France, they agree nicely. So this means that we can be more confident that our findings are actually good reflections of what our guests might experience on their journey. Once we know a wine region, because travelers told us so, it's much easier to recommend in the future a similar place to a customer with similar intent and similar customer profile. I'm also happy to have heard that in the intro talk that a similar approach is being used by Google. Now, to narrow down from the regional level to the city level, of course, the complexity augments. So, because we are working at a higher resolution, right? So the challenge here becomes, again, what experiences can we recommend, but no more in this general dominant team way, but really at the individual item. So what kind of points of interest we can recommend. And this is something that I work personally on. So in a sense, like, because of the higher complexity, we need to step up. It's no longer enough to work with a simple keyword-based text, but we actually need to rely on free-form text, so on the real user reviews, no longer on endorsements. And what we do here is we detect significant entities for every destination. So what I'm doing, I'm deploying an R model and named entity recognition to detect mentions of points of interest. And subsequently, with an aggregation function, I simply estimate the number of mentions. So we have an example here of somebody who wrote dreadful weather on our visit to Amsterdam. And as an Amsterdam citizen, I totally agree with that. But we enjoy Rijksmuseum and Van Gogh Museum. So these are the kind of entities that are detected and counted. Now, this is very interesting because, for instance, as we consume OSM data, we are able to actually detect what part is more relevant for our business. As a sort of naive validation of this approach, I compared top detected points of interest with the most touristic areas, the areas for which we have more traffic. Of course, this is a fairly aggregated view for business reasons, but you can see that there is a strong positive correlation between highly touristic areas and highly mentioned points of interest, which is what common sense will dictate, but these are exactly the results that we expect to see. Again, the point here is that from a product-wise perspective, this is similar to the wine region example. We leverage non-traditional spatial data sources to mine what our users find interesting and exciting in a certain location, right? What experiences they think it's worthwhile to recommend. So we can learn this from them in order to ourselves then repurpose this content and recommend it to the next customer. And lastly, and this is something that it's more experimental and currently working on, is a combination of the previous technologies and data sources. So the goal is here to combine social proof, what I presented so far, so what we mine from our users, with on-the-ground data, such as OpenStreetMap, to truly capture the local context of a destination at scale. To do this, I'm leveraging well-known technologies, such as spatial indices, to produce machine-readable geo-features, really, that I can use to enrich our machine learning models with location data. And again, I'm happy that I've heard this approach from BigQuery, where they were generating geo-features at high level. Right, so I hope I give you so far a bit of taste of what we do, and that I will summarize in 3 main points. So today we consider spatial data not only traditional GIS data formats, but also text, images, and tags, and all kinds of other data that can be somehow anchored to space, pinned on a map. These are quintessential part of everyday spatial data scientist job. Of course, this data transforms the way in which we work. So Javier before mentioned how machine learning is becoming much more prevalent and how GIS professionals are transitioning towards this new area of expertise. This new data sources transforms also the way in which we can provide the best traveling experiences to our customers. We can rely on more data and more descriptive data based on the location in which we are operating. This clearly opens new opportunities for spatial data scientists and for spatial data science in general, where we can enable machine learning models to deal with spatial data and thus better explain the world and thus better recommend experiences for our customers. So with this, I think I'm also running out of time. Before concluding, though, I'd like to give a huge shout out to all my colleagues, those mentioned and those here, with whom I work every day. So this is all for me. And please, if you have any questions, I'm ready to answer. Thank you.
Hi there, Michele.
Hey.
We do have a few questions, some of which have had some answers, I think, in the chat, but I think it's best that we ask you to hear it from the horse's mouth. First of all, Philip Carew asked us, when using OpenStreetMap's data, how does Booking validate that POI is still there or open? How do you do that validation process?
Right. Yeah, so this is part of the what I was presenting with the NER model. We obviously know the time of the review, when it has been written, and this is like, it's an ongoing process. So in a data validation pipeline, we can account for time factor and check that somebody wrote about a particular points of interest last month, in the past 6 months, or last year, and kind of factor for this time dimension. This also raises a slightly similar point, which is seasonality of points of interest as well, which we can infer again from the time dimension of our reviews. Of course, some points of interest are relevant during summertime in particular places of the world, in the North Hemisphere and the South Hemisphere, and others the opposite, right? So yeah, this is how we do it in a sense.
Okay. We have got quite a lot of questions, so I'm going to see if we can get through them. So the next question is from Paula Romero, who has asked, which databases are Booking using, or which database?
Yeah, I mean, all the overview that I presented at the beginning, it's really our own database. So this is something that we historically, through time, accumulated. These are items that we think are relevant for our customers, that we have validated again through social proof, that we know are interesting for people to experience when they're traveling, really.
Okay. And Shanaha Sivakumar, I hope my pronunciation's okay. Do you use natural language processing also to find high frequency words and group them to pinpoint a particular attraction?
Yes. There's an example which I had to leave out because of time constraints. It's a similar technique. It's just a simple TF-IDF. This was done by my colleague Tyler, which enables us to really pinpoint the uniqueness of certain places. So again, NLP combined with geo can really help us pinpointing what is going on in a certain area as the most distinctive characteristic. We model endorsements, which again are the set of labels attached to destinations, to cities, really. And we can find the most distinct characteristic of a place. So I remember you're based in Spain. Paella is one of the topics that come out fairly often. Shark diving in South Africa, or there's a chocolate factory that I never heard of, but North Americans might be familiar with in Pennsylvania, the Hershey's chocolate factory. These are funny examples of things that our users find actually exciting to explore in a place.
Wow, hopefully they are mentioning chorizo with the paella, because that's always very controversial. Fascinating. Really enjoy the examples. Thank you. The other question we've got here is from Nimrod Gavish, who asks, I assume the basic unit of analysis you used here, the hexagon, is where the guest accommodation is located, correct? If so, how do you account for tourists that don't necessarily stay in this area?
Sorry, I missed the first part of the...
So Nimrod assumes that the basic unit of analysis you use, hexagons, is where the guest's accommodation is located, right?
Mm-hmm.
If so, how do you account for tourists that don't necessarily stay in those areas?
I guess he was referring to the POI validation example.
Yes.
Yeah, I mean, as I said, it's just a naive form of validation. So in a sense, like I just wanted to see, is there any correlation between highly mentioned places and highly mentioned things to see? It would be interesting, of course, to kind of combine the graph example that I show, those substitute location, so London for Cambridge, London for Brighton, to kind of account for substitute places or alternative destinations. Yeah.
Okay, and I think we have time for one more question, which is: are you doing names? A couple of people have asked the same question here. Oscar, Holm, and I think we've also got the same question from Li Ming Tan, who wants to know: are you doing name density recognition in different languages, or are you just focusing on English initially?
No, yeah, that's a fair point. We operate in many countries in the world, and we have to translate our content, I think, in more than 30 languages. So, of course, we do have availability of reviews in different languages, and also of the POIs that are detected in many languages. So, yes, we do multilingual identity recognition.
Okay, fantastic. That's helpful for the team. I see that there are quite a few more questions coming through. I'm conscious that in 1 minute we're going to be starting with our next presenter. Michele, I wanted to thank you for your time to prepare the presentation today. It was great to hear your story. It's got some great feedback on the chat. I'm sure you can take up those conversations over on the chat now. Yes, I hope the weather in Amsterdam improves.
I hope so too. Thank you for having me. It was a pleasure.
Thank you. And now we're going to go on to the next chat, which is going to be with Andrew Stringer from BT. Andrew is an evangelist for all things location, GIS, spatial within BT, and spent most of his career working in location planning. And I'm really looking forward to hearing his talk now. So I will hand over to Andrew. Welcome.